Alrighty, hey again, Honors Chemistry. I wanted to do the last question on worksheet number 2 in Unit 9. And so I just want to do one last stoichiometry and PV equals nRT example. I'll write that. Stoichiometry using PV equals nRT. Okay, so you're going to see a couple of questions like this on your final, and you need to know how to plug and chug into this equation. So it says nitrogen gas and hydrogen gas combine to produce ammonia, NH3. Let's write that equation. Nitrogen gas plus hydrogen gas combine to produce ammonia gas, which is NH3. I'm going to put the gas symbols on. Okay. Now, why did I know to write nitrogen and hydrogen as N2 and H2? Because of Hofbrinkel. Now, if I want to balance this, and I'll go back to using particle diagrams, N2, H2, and I have NH3. I have too many H's on here, over here. Now I need to add another one of these. And now I have two N's, and I need to add another one of these H's. And now we're good. I have one N2, three H2s, and two NH3s. Okay? And so now it says, what volume of hydrogen gas at 25 degrees Celsius and 735 millimeters of mercury is required to completely react with 10 grams of nitrogen? So I will begin to construct my BCA table. To remind myself that I need to have moles in here, so BCA. I have 10 grams of nitrogen, which is N2, divided by 28 grams per mole of nitrogen. That is the molar mass of N2. One nitrogen is 14, so two nitrogens would be 28. 10 divided by 28, I get 0.357 moles of N2. All right, so that goes right here, 0.357 moles of N2. It says, what volume of hydrogen gas is required? So I don't care about ammonia. It's talking about nitrogen to hydrogen. I could do my dimensional analysis bid, moles of N2, times 3 moles of H2 over 1 mole of N2. And I end up getting 1.071 moles of H2. That's how much I need. It's a 1 to 3 ratio, so I really just multiplied by 3. Okay? If you use Kirsten's way, you would say, okay, divide by 1, multiply by 3, same answer. Okay? Now that I know my moles of hydrogen gas, the question says what volume? Volume is nRT over P. That's from the original equation, PV equals nRT, but I just rearranged it. And so now let's record all the variables I got. I know that my N is 1.071 moles of H2. My T was 25 degrees Celsius, which is equal to 298 Kelvin. My P was given to me as 735 millimeters of mercury. But really, if I divide by 760 and I get my atmospheres, I get 0.967 atmospheres. And let's see, am I missing anything else? I got P, T, N. Of course, my value for R is always given to me. That's a constant. That's not going to change. Liters times atmospheres per mole Kelvin. And now I'm looking for my volume. I don't know. All I'm going to do is plug and chug now. So now I have 1.071 moles times 0.08206 liters times atmospheres per mole Kelvin times temperature, which is 298 Kelvin. Everything's getting squished, and I'm sorry here. All right, I'm plugging in my numbers here, 298 Kelvin, and then over pressure, which is 0.967 atmospheres. If you do this math correctly, you should get a volume for H2 being 27.08 liters of H2. That's what needs to be, or what is required to react with N2. Okay? All right, there goes the extent of me showing you all these videos. So I definitely did Three separate examples of stoichiometry using PV equals nRT, so hopefully that'll help you with the other questions in worksheet number 2. I applied and used PV equals nRT many different ways, and I recapped and showed you how we do BCA tables, especially if I just have straight up stoichiometry, and then eventually I use PV equals nRT. Alrighty, that is the extent of what you need to know for this week and with worksheets 1 and 2. So make sure you either watch these videos or keep in track with understanding gases and stoichiometry.